Hello students, welcome to this lecture number 5. In this lecture we will be going to discuss the concept of pH, and this is a part of the Ionic Equilibrium chapter. This is K.K. Mukherjee in the Science with Mukherjee's YouTube channel. So today we are going to discuss the pH of any solution. We know Kw, that is ionic product of water, that is fixed for any solution at a particular temperature. Suppose we are taking that. So at this temperature, what we find, the Kw ionic product is 10 to the power minus 14. And it is fixed for any type of solution, whether it is neutral solution, whether it is acidic solution, whether it is alkalic solution. For neutral solution, we can write it for neutral solution. The concentration, we are talking about the molar concentration of hydrogen ion and molar concentration of OH minus ion, that will be same, and it will be 10 to the power minus 7. For acidic solution, it is the H plus ion will be greater than 10 to the power minus 7 and OH minus ion is less than 10 to the power minus 7 mole per liter. For basic solution, the H plus ion is less than 10 to the power minus 7 and OH minus ion is greater than 10 to the minus 7. And all the cases, that is in the acidic solution or basic solution, the product of this mole concentration of H plus and the OH minus ion is always fixed, and that is 10 to the power minus 14. So the conception came that if it is a fixed quantity, then we can express all these solutions, that is neutral solutions, acidic solutions and basic solutions, in terms of the concentration, molar concentration of H plus ion. And that is what Sorensen, the scientist, proposed a concept of pH. pH is basically the potent dihydrogen. Potent dihydrogen is basically, in Danish language, it is called the power of hydrogen. It is called power of hydrogen. Power of hydrogen. And we can express this, the molar concentration of the H plus ion, as 10 to the power minus x, whereas x is the pH. So we can simplify it that pH is minus log of hydrogen ion concentration, and whereas we are keeping the base of the log, which is a 10. So what is pH? We can further define pH. It is basically the negative logarithm, with the logarithm is taken with the base 10 of the hydrogen ion concentration. That is the pH. And this concept has very useful in other species also, that we will discuss later on. So pH is this. Now pH is, there is a scale of the pH. Everything has a scale. Suppose meter scale, everything is a scale, like this pH as a scale. Now we are going to discuss the scale of the pH. The scale of pH. That is very, very important. And we are taking here the molar concentration of H plus ion and the pH is another. Suppose the molar concentration is 10 to the power 0, means 1 mole. At that time the pH will be 0. When it is 10 to the power minus 1, its pH will be 1. When 10 to the power minus 2. So this is a pH scale, you can easily understand, and this is very, very important to understand the pH, that this is the concentration of H plus ion, and this is, as against this concentration, what will be the pH of the solution when the concentration is 1 mole, 10 to the power 0, that is means 1 mole. Then when the concentration is 1 mole, then it will have the pH 0. When 10 to the power minus 1 means 0.1 mole, molar solution of H plus ion, then pH will be 1, then 10 to the minus 2, then pH will be 2, and in this way you can see as the H plus ion is decreasing in the solution, the pH is increasing. That is to be understood. That is a very important thing. As the H plus ion, concentration of H plus ion is increasing, the pH value is decreasing. Here you can see concentration is decreasing, pH value is increasing, and you will find a point where that is pH equal to 7. At that time 10 to the power minus 7, the H plus ion concentration is 10 to the power minus 7. At that time you will see this pH is 7. That is the pH of the neutral water. Simple pure water have the pH 10 to the power minus 7. This is pH 7, but as against its H plus ion concentration is 10 to the power minus 7. And as we increasing, the pH goes on increasing, and this is a cutoff point where we can bifurcate the two solutions. That is, one is the acidic, this point is acidic solution, this acid, and this point is the basic solution. And it will go up to the scale of the pH, go 0 to 14. So we can understand the scale of the pH. It is basically depends by the difference of the H plus ion concentration in the solutions. When the pH is less than 7, we will say it's an acidic solution. When it is greater than 7, it will be basic solution, and it is 0 to 14. Okay, so pH we understand that is basically the negative logarithm of H plus ion concentration, where the log is taken as a base 10. To understand this concept, we have some numericals that will give you lot more clarity. Calculate pH of 10 to the power minus molar HCl solution. So we know pH is basically the minus log of H plus ion concentration. Okay. So what is the H plus? 10 to the power minus 8 moles, that is given by log of this, and we will get pH is 8. But as it is an acid solution, this is not possible. So what will be the pH of this solution? That will be understood. What we have done a mistake here, we have not considered the already present H plus ion which comes for the self-ionization of H2O. For the self-ionization of H2O, you will find there will be the H plus ion concentration at 25 degrees Celsius, that is will be 10 to the power minus 7 mole per liter. We have not considered this. That is why this problem comes. So now, and this 10 to the power minus 7, the concentration of the H plus ion. So we can write concentration of H plus ion, that will not be 10 to the power minus 7 because it is acidic solution, that is more than different, that we will first calculate this X. So if it is a H plus ion concentration is X, then OH minus ion concentration will be also X. But here you can see is the acidic solution, it will having the pH, it is a concentration of the H plus that is added. So total H plus ion concentration is how much? This will be, you can see, X plus 10 to the power minus 8. Total concentration of, we can write concentration of H plus ion, molar concentration. Okay. So we now put this equation that we know the ionic product of water, that is H plus ion concentration, and this OH minus ion concentration will be 10 to the power minus 14. Okay, and this equation we can again put this here, that is X plus 10 to the power minus 8 into X is equal to 10 to the power minus 14. So it will comes a quadratic equation. From this quadratic equation, because we know the roots of this quadratic equation will be minus b plus minus root over b square minus 4ac. Okay, by 2a. So if we put all the values, we will find the X is coming around. I am not going to the detailed calculation. That will be coming around 10 to the power 9.51 10 to the power minus 8. Now we put this value down. This is the X. X is basically the concentration of the OH minus. Concentration is OH minus. So now now the total what will be the total H? Total H plus ion, that we can calculate from this. Again we can use this H plus and OH minus, and product is 10 to the minus 14, and we put this value, we will get H plus concentration will be 10 to the power minus 14 divided by 9.5 into 10 to the power minus 18, and it will be comes around 1.05 into 10 to the power minus 7. So we know what is pH. pH is basically the minus log of hydrogen concentration is this 1.05 into 10 to the power minus 7. So it will be coming around 7 minus log of 1.05, and 1.05 is, if you see, that will be 0.02, and it will be coming around 6.98. So you can see the pH of this 10 to the power minus 8 molar solution is slightly less than 7. Okay, and this is a very important concept that it can easily confuse you. In the exam, this will come and you will go straight forward with this formula and you will get this 8, but this is not the correct answer. In the option you will find that 8, one option is giving 8, one option is giving 7, this type of option you will give it. But if you know, then you can write the right choice. Okay, now we go another very important good questions. Question number 2 we have taken that a solution is given a solution of 10 to the power minus mole of HCl solution, suppose acid solution. It is diluted 1000 times, right? And what will be its final pH? Calculate. Final pH. What will be the final pH of the solution when a solution you have been given the 10 to the minus 6 mole per liter and it has been diluted 1000 times, and calculate its final pH. What we will get? So the molar concentration initially of H plus ion initially was 10 to the power minus 6. H plus ion 6. So when is diluted? Diluted means H plus ion now will be coming around 10 to the power minus 6 by 1000. And this will be given 10 to the power minus 9. Now again that same problem will come when we put this value directly in the formula minus log of H plus ion concentration. Then it will come 9, but that is not possible. And in that time what we have to do again, we have to take the assistance 10 to the power 7. Suppose we have taken the 10 to the power 7 plus 10 to the power minus 9, that will be the H plus ion concentration, because we have to add this what is for the due to the self ionization of the water that is coming out 10 to the power minus 7, and it will be this, and total H plus ion, total H plus ion concentration of the H plus ion will be this, and it will be coming around 10 to the power 7 1 plus 10 to the power minus 2. So it will be coming around 10 to the power minus 7 is 1.01. So you have to now calculate this amount. So you will find it will be coming around, the pH will be coming around 6.996. So this type of confusing question comes and you have to clearly understand the concept, then you can able to understand, they can able to give the proper answer to that question. Okay. 0.365 gram of HCl gas passed through a final pH. You have to calculate the final pH. What is going to happen here, when acid is being passed through a solution of 2 moles in UH, what is going to happen? That there will be neutralization, because the acid and base will neutralize itself, and you have to see that whether this acid which is given, which is passed through the solution, whether it is sufficient enough to neutralize it. If it is not neutralized, then what is going to happen? Now there will be some portion will be either it will be acid or either it will be alkali. And accordingly, the pH of the solution you have to find out. So you have to find out what is the first. You have to find out the moles per liter of HCl gas. From this data, you have to first find out mole per liter of the HCl gas, and that we will find, that is here given the grams of this. From this you can able to calculate the moles. So moles of HCl is, you can write, that is 0.365 by 36.5 because molar mass of the HCl is this. So it will be coming around 0.01 mole. Calculate it, it will be coming around 0.01 mole. So this 0.01 mole has been found in 100 centimeter of the solution. So the mole per liter of the solution will be how much? Now that is the mole divided by your 100 into 1000. So it will be coming around the 0.1 mole. So 0.1 mole of HCl, we neutralize 0.1 mole of NaOH. So remaining NaOH is equal to your 0.2 minus 0.1, it is equal to 0.1 mole per liter. So pH, you have to calculate the pH, but now you calculate the pOH. pOH that is given by, now sorry, you have to calculate pOH, that will be the relation that will be discussed later on in this video itself. Now we can see the concentration OH minus ion is given, that is 0.1 mole. Okay, it is remaining. So when it is 0.1 mole is remaining, then we understand this relation, from this relation, that is H plus ion and OH minus ion, the product is always this 10 to the power minus 14. Right? So this is 0.1. So what will be the concentration of H plus ion? This will be given by 10 to the power minus 14 divided by 0.1, and it will be coming around 10 to the power minus 13. So now we can able to calculate the pH. pH of this solution will be, we know, minus log of hydrogen ion concentration. So it will be coming around log of 10 to the power minus 13. That will be given by 30. So pH of the solution will be 30. Okay? Very important relationship that we are going to understand, that like a pH is a very basic concept, and from this concept different concept has been evolved. Like that we can write pOH, this is the concentration of hydroxyl ion, that is pOH, basically the log of minus log of OH ion concentration. Then we can also pKa, basically the minus log of dissociation constant of weak acid. pKb, that is the minus log of dissociation constant of Kb. This is constant of base. pKw, that is minus log of Kw, means 10 to the power minus 14, so it will be coming around 40. Now we have a good relationship with the pKw, pH and pOH. What is that relation? The relation, you know, that Kw, Kw is equal to H plus ion concentration and OH minus ion concentration. Okay. So if we take the log of both the sides, we will find log Kw, it will be log of H plus ion concentration, then log of OH minus ion concentration. So if we take the negative all the cases, we will find the pKw is equal to pH plus pOH. That is a very, very important relationship that we must understand. Okay? Very important relationship. So, this is a very important relationship. Now, we are going to deduce one relationship, that is K and Kb is basically the K is dissociation constant. You can write K is equal to the dissociation constant of acid, and Kb is the dissociation constant of its conjugate base. That's a very important relationship. Suppose we are taking the HF is a weak acid, and this acid when is ionizes, it will give this. Now dissociation constant of is will be K is equal to H plus into F minus divided by HF. Now this is the acid and its conjugate base is F minus. Now you see the dissociation constant for this F minus base, that is we are giving by this, when it will be dissociate F minus H2O, that we will given by is HF plus OH minus. So what will be the dissociation constant of this conjugate base Kb, and we can write HF and OH minus, and that is given by F minus. We are neglecting the concentration of H2 because it is in excess amount, and its concentration, molar concentration of the H2, which is in excess or in the pure, will not going to change. So it will be constant. We are not taking. We are taking as a 1. So this will be this. Now if we get Ka into Kb, if we multiply this, and we will get this a very important relationship. This relationship very important. This will go to this, and this is basically the Kw. So that is the another very important relationship, that is the dissociation constant of the acid and dissociation constant of its conjugate base. This is the dissociation constant of acid and its conjugate base, and it is been correlated with the Kw. Okay, that is all for today's lecture. In this lecture we have we have discussed lots of things about the pH and all the basic relationship that will going to help us in the next classes. Okay, all the best and be best, and thank you very much for watching it. If you like this video, you can share to your friends. Thank you.